Now, today we will see this one, stationary points and finding equation of a tangent. Okay, so this is edXL GC Core Mathematics C1 Advanced Subsidiary question. So anyway, you have the same concept everywhere. You have the same concept. There is no change. So stationary points already you know how to find this. We will also see how to find the equation of a tangent. Okay, so the curve C has equation y equals to x cubed minus 2x squared minus x plus 9, where the given domain is x is greater than 0. The point P has coordinates 2, comma 7. Okay. Uh, show that P lies on C. Okay. So what does he wants to say? The curve C has equation is given. Okay. So the point P has coordinates 2, comma 7. Show that P lies on C. Okay. This is a general question. Okay. How would you prove, Sarah, if this point P lies on this, what happens actually? That should satisfy the equation, right? So
Yeah.
yeah, I won't use any calculus in this. Instead, I'll just substitute the value of x, that is equals to 2. Okay, the value of the x coordinate is 2, and I'm expecting what? Now I'm expecting y as how much? 7. If I don't get 7, it means it's not lying. How much this gives to 8 minus 8 minus that's plus 7. So that is 7, isn't it?
Yeah.
Yeah. So I'm getting, if you substitute x as 2 in this question, in this equation, I'm getting y as 7. So it means 2, comma 7 lies on this, isn't it?
Yeah.
Now find the equation of a tangent. Yes, this is what we are going to discuss today. Find the equation of a tangent to C at P. Okay, giving your answers in the form of y equal to mx plus c, where m and c are constants. Okay, so you have this function y equal to x cubed minus 2x squared minus x plus 9. Okay, so how to find the equation of a tangent, I'm going to explain here. Okay, so just assuming the equation, what was that? Y equal to x cubed minus 2x squared minus x plus 9, isn't it? Yeah,
Yeah.
this was my equation, where x is greater than 0. The tangent is at P. That's that's the important point here to be noted. The point, at what point are we finding? At point P, that is 2, comma 7, right? Yes.
Yeah.
So it's 2, comma 7. This is my point P. This clear? Yeah.
Yeah.
Now, how to find the equation of a tangent now? First thing you all should remember here is, when I say equation of a tangent, it's nothing but a straight line, isn't it? The equation of a tangent is a straight line or a linear one or a non-linear? Straight one or a non-linear? Not
It's
equation of
straight.
it is straight. Yes, it's always straight, isn't it? Whatever
Yeah.
curve you have, suppose if I have the curve like, if I have curve like this, okay, if I draw a tangent here, the stationary point, I have to draw in this way, isn't it? It's, it just touches the peak point and it's, it's passes. It's not just the peak point. I can also draw the tangent somewhere here, okay, like this. Yeah. But thing is, I have to understand here, the question it says is, I have to find the equation of a tangent, not at every point of this curve. I have to find at what point. They are very specific, 2, comma 7. So let's say this is the point 2, comma 7. Okay, will that be okay? Let's say this is the point 2, comma 7. And suppose this is the function y equals to x cubed minus 2x squared minus x plus 9. Okay, you can use your Desmos calculator or graphic calculator. You'll get the exact, how does it look like? Y equal to x cube minus 2x squared minus x plus 9. Okay, you'll get to know. But we don't need how exactly it looks, to find the equation of a tangent. So how to do that here is equation of a tangent. It's a straight line. You should understand that the first point is this is a straight line. How do you find the equation of a straight line? Generally, how do you find the equation of a straight line? Yeah.
Equals mx plus b.
Okay, this is standard form. The another form, when you have the point form, when you have been given the points, you can also use this one, right? Y minus y1 equals to m times x minus x1, right?
Yeah.
Where x1 comma y1 are the points, any point lying on the tangent, isn't it? Because I'm finding the equation of a tangent. Now you see here, this is the tangent. I'm going to find the equation of this red line, the tangent. Can you tell me a point lying on this tangent which you are knowing it? I mean the known point which is lying on this tangent. Which point is that? 2, 7, right? So this is x1 and this is y1 here. Okay, is that clear? Yes.
Yeah.
What about this m? M is the gradient. Now to find the gradient, I'm going to use the calculus because I don't have 2 points on this tangents. Otherwise I would have used that that method to find the equation, to find the gradient of the straight line. Instead, I'm going to use the gradient, the calculus form, that is dy by dx. Okay, instead of m, I'm going to use here dy by dx. Dy by dx, differentiation of this, of what? Differentiation of this curve, at x equals to 2. If I do this, I'm going to get the slope of this tangent, which is passing through this point. Okay, so I'm going to find the gradient of this red line which I was having here. I'm going to find by using the concept of calculus. Okay, so how I'm going to do is very simple. Just differentiate this function. Okay, so dy by dx would be equals to differentiation of x cube is 3x squared, differentiation of 2x squared is 4x, and differentiation of x is 1, isn't it? Yeah, and the the differentiation of a constant is 0. Is that clear, Sarah? Yeah. Now I'm finding at x equals to, I'm finding this gradient at x equals to what? 2, right? So I'll just substitute this 2 here. After differentiating, I'm substituting 2. So I got the value of m as what? 12 minus 8 minus 1. So I'm getting as how much? Will you try this? Just try this. How much I'm getting? It's 12
3.
minus 1. How much is 5? 3 or 5?
Yeah.
How much? 3, right?
3.
3. So I got the slope as, the gradient as 3 here, isn't it? I also know what is y1 and x1. That is 2, 7. They are the points, any point lying on this tangent. And also remember, this point is known as point of contact. This is, you should know this. Okay, this is in contact between the tangent and this one. Okay, so now I'm going to use this formula directly here, the straight line formula. You are having y minus y1 equals to m times x minus x1. So what is y1? That's 7 versus m. I got the slope, the gradient as 3 at x equals to 2, right? So 3 and x minus x1 is 2. So I got 3 times x as 3x, 3 times 2 is 6. They are very specific about the form y equals to mx plus c. So I'll just put this in y equal to mx plus c form. For that, I have to isolate y, isn't it? So I got y equals to 3x plus 1. This is how we are going to find the equation of a tangent. Is that clear? Okay.
Yeah.
Now, in this question, we have seen how to find y equal to 3x plus 1, the equation of a tangent. Now we also see, now we can also see there is something given in the next sub question. The point Q also lies on C, given that the tangent. Oh, so he says that the question says the point Q lies on C. The C is nothing but what is C? Actually, it's a equation, right? It's a curve. It's nothing but this curve. Okay, so this is C. The name of this curve is C. That's not given by me. It's given in the question itself, the curve C. Okay. So the point Q also lies on C. I don't know where it lies. So given that the tangent to C, okay, at Q is perpendicular to the tangent to C at P. Now this is interesting question. They are trying to mix. They are trying to combine multiple concepts in this question. The point Q also lies on C. So where is it lying? Given that the tangent to C at Q. So I have to again consider the same picture. Let me take this picture. Okay. Hold on. I'll just draw the same picture here. I have something here, isn't it? I have the tangent as well, isn't it? Where was my tangent? Like this is not the exact diagram how it looks. This is just my rough diagram. Okay, you don't have to take this exactly like this. I have the tangent here, and equation of a tangent is y equals to 3x plus 1. Right, Sarah? Yeah. And now,
Yeah.
and what was this point? 2 comma 2,7, isn't it? Yeah, this
Yeah.
was the question says the point Q lies on C. So this is my C. I don't know where it lies, but wherever it lies, suppose if I say it lies here. Okay, let me assume the point Q lies on C here. Given that the tangent at C at Q is perpendicular to the tangent to C at P. So what does this mean? What does this mean? Yeah,
It's the same.
it's the same thing, but there is some relation. He wants to say that there is a tangent here, isn't it, from Q? Do I have to find again different? Do I have to again differentiate? No, I already know what is differentiation. I have already differentiated the function earlier. That is, I got this 3x square minus 4x minus 1, right? I just
Yeah.
have to change my point. Initially, I have find the value of I have found the value of gradient at x equals to 2. In the question, in this question, we are also finding the value the gradient at q. What is the point q? Do I know what is point q?
You know the x coordinate.
What is that?
1/3 bracket
No,
2.
no, that is what something I have to show that. I don't know. I have to show that. I have to prove that x equals 2. Okay, so the interesting part is they haven't given you what is they haven't given you neither x nor y. Nothing is given here, isn't it? So but thing is, given that the tangent to C at Q is perpendicular to the tangent to C at P. What does this mean? What does this mean? This tangent is what? Tangent to C at P, isn't it? The tangent to C at P is this one, right? Yeah. And
Yeah.
the tangent to C at Q is this one. Unfortunately here, they are perpendicular. So that means the graph will not look like this. Is that clear? So it will look something different. So how does it look? Maybe, maybe let's see. Maybe it looks like, maybe it looks something like, like this. Maybe if you turn this here, suppose here, or suppose if you consider a tangent like this. Wait, hold on. If you just twist this, if you draw in this way, or suppose I have another point Q here. Okay, this is the point Q. If I draw a tangent to this, what happens? They are perpendicular, isn't it? Yeah, maybe the graph looks something like this. Clear? Yeah.
Yeah.
Yeah. So anyway, the point, the both the tangent, this one and this one, they are perpendicular. When they are perpendicular, there is a condition. What is that? When two lines are perpendicular to each other, the product of their slopes is equal to -1. Do you know this? So if there is a line 1 or any tangent or a line, it can be anything. If this has slope m1, if this has, suppose, let's say m2, if they are perpendicular, the product of the gradients is equals to -1. Okay, so let me take the gradient. Suppose this line has the gradient m1, and how much was the gradient for this line? That is 3, right? You can see here y equal to mx plus c. You have the gradient 3. Also, you can also see we have initially found that the gradient is 3 at the first point, right? Yeah. So
Yeah.
I'll substitute m1 as 3. Now I'm going to put the value of m2. So m2 is -1/3, isn't it? Yeah.
Yeah.
Yes, -1/3. I got -1/3. So this m2 equals to -1/3 is a gradient of this second line, second tangent, which is passing through Q, isn't it? Yeah, because they are perpendicular. This is m1. This one is m1. The slope for this line is m1, and this for slope for the other tangent, which is passing through Q, which is touching through Q, passing through Q, it's m2. So I got m2 as -1/3. Clear? So yeah. So what I'm going to do is, now I have this one, dy by dx, gradient is equals to 3x square minus 4x minus 1. I'll just equate this is equals to, how much did I get gradient? Dy by dx, how much I am getting? -1/3. By doing this, I'm going to get the value of x for this. Clear? Yeah, let's see.
Yeah.
3 times 3x square minus 4x minus 1 equals to -1. So 9x square minus 12x plus 3, isn't it? Isn't it? A is equals to -1, comes here, that becomes +1. Yeah. And there
Yeah.
is some minor change in this. Minor changes. Here is -3, right? 3 times -1 is -3. Now you have 9x square minus 12x, -2 equals to 0. Yeah, isn't
Yeah.
it? Yeah. If you use the formula, or if you use calculator, there you have the formula. This is a quadratic equation. You have formula -b plus or minus b square minus 4ac upon 2a. Now minus of -12 plus or minus. I'm using this. You can use GDC. Okay. So this is -12 square minus 4 times 9 times -2. Is that clear? Over 2 times 9, right? So you got negative times negative is positive, plus or minus. How much this will gives to 144 plus 72, right? Yeah. So upon 18. Also, I have 12 plus or minus. What is 144 plus 72? 216, isn't it?
Yeah. 16.
16. Can you tell me what is in the third form? Don't solve it. Just what is under root of 216 gives to what? You can see here the factors of 216, or otherwise you can use the calculator. This is 6 times 36, right? And 6 times 6. So I'm getting as 6 root 6, isn't it? Yeah, this pair is 1. Yeah, so 6 root 6 upon 18. Now I have to show this. I think I'm almost done. Yeah. I can take 2 common. I'm getting 2 plus or minus root 6 upon what? 18. And what is 6
Yes.
by 6 over 18? That's 1 over 3. 2, yeah, plus or minus 6. Okay. Yeah.
Okay.
Now the thing is, I can't, you got the two values of x here actually, but reality is here, like that is true obviously, but in the question, if you see here, what it says is, in the question here, if you see, x values are greater than 0 here, isn't it? So you are
Yeah.
not taking anything, in this region. Okay, you're not taking anything in the region where x-axis is negative. So you're taking everything to the right side. So there might be a tangent which is formed in the negative x-axis, but we are not considering that one. So I just have to consider which one? Positive value, that is 1 by 3. Yeah, and I have to write in proper form. Yeah, 2 plus root 6. So this is my x coordinate. I have to neglect that minus, because 2 minus root 6 is it's going to produce a negative value. So this is how we have tried to find out the value for this x coordinate. Okay, we are not interested to find the y coordinate here, because we have not been asked to do that. Okay, so that's how we